Hi, my name is Malika, and I am one of the members of the ERSP group. Hi, my name is Malika, and I am one of the members of the ERSP group working with Dr. Hanea Ismail Beji. Today, we will be presenting our project on the use and effect of a wearable tongue-computer interface to aid with software interactions on a smart device. This project is a smaller part of a project by our graduate advisor, Sylvia Rossa, who has written an extended thesis on user interfaces for tongue-controlled devices. Our research and results have been guided by both Sylvia and Dr. Ismail Beji. And the participants in this group for this semester were Mahal Schroeder, Anya Ellis, Mariam Ahmed, and Malika Patel.
Reliable, user-friendly assistive devices are necessary to ensure that individuals with disabilities are able to efficiently utilize technology to proceed with their daily lives. Nowadays, there are numerous text-to-speech devices that perform a variety of tasks for these individuals. These devices strongly depend on the design of the assistive device in terms of aesthetics, capability, and user-friendliness. As up to 1% of the world's population suffers a degree of speech problems, there are high-tech augmentative and alternative communication methods that are constantly being improvised to improve the lives of individuals suffering from speech-related difficulties. But current solutions are disadvantaged in the method of handling interactions between the user and the assistive communication device. Our research revolves around a discrete wearable device that fits inside the mouth cavity. It implements tongue-to-speech technology in order to achieve a similar outcome to current assistive devices. The device currently transmits user input through Bluetooth Low Energy. These interactions can be improved upon through a sophisticated yet simple user interface. The focus of the research plan revolves around creating functionalities in a mobile application that will support daily tasks in the use of the wearable retainer and fabricating concise methods of experimenting with the overall efficiency of the implemented functions in the app.
The problem statement for our project was to design a user interface for an application that is controlled by the tongue. The application was to take traditional applications that were often utilized by users, such as calculators and settings, and transform those applications to increase the level of user friendliness and allow a wider range of users to connect to the mobile environment. This problem was developed by looking at our background research and identifying what part of the process needed to be modified for a wide range of audiences to be able to use tongue-controlled devices.
Hi, my name is Anya. I'm here to present the project goals. We develop functions to assist the mobile application for the wearable retainer. We tested these functions for accuracy as well as proper input and output methods, and we wanted to produce code that aligned with the ADA regulations, which we did so wonderfully. We also wanted to write this code in a way where both iOS and Android devices could use the code. iOS and Android are the two most prominent operating systems for smart devices, and we found that the React Native libraries would allow for us to make code that could be used by both operating systems. The functionalities that we built was the GPS, calculator, settings, and calendar. And the next slide will be the methodologies.
The method The method of developing and executing this project was complex since they involved building and writing code in React Native framework. The framework required a long installation process, followed by several updates throughout the course of our project. We first began developing the application in Expo SDK and then switched to running a native application on Android emulators. First, the emulator we used was Knox, and then we switched to the React Native Android Studio emulators. Running applications on Android emulators was restricting, including not allowing Bluetooth services and airplane mode services. However, it did not completely hinder our effort to develop functionalities. A lot of our applications also required built in JavaScript functions that were necessary to test. For example, our calculator required the eval function, which needed to be tested with edge cases such as 0 divided by 0 and others. Other research methods we utilized also consisted of checking cross platform functionality of the application itself, meaning, in other words, that it needed to be compatible with both permissions on Android as well as iPhone and iOS devices. Some of the challenges we encountered while developing functions were the calculator operations. These needed to be input in a certain manner. The GPS position tracking was also a hard issue to resolve, and the settings voice control was difficult since it required the ability to request access to permissions to change the settings of the entire phone. Thus, the functions needed to account for multiple inputs, which made our testing difficult. And also, we still have development ongoing on the implementation of two inputs at once, um, meaning meaning two different touch points on the phone screen to take and realize input.
In the school section of the app, one of the first functionalities we coded was a calculator. The design of the calculator allows it to be more user-friendly because of the layout in contrasting colors. The buttons are also clearly defined and do not have an all-white background, as shown in some Android calculators. 5 main functions were included: addition, subtraction, multiplication, division, and square root. The React Native calculator also allows for both positive and negative input, as well as non-integer input. Testing for the calculator was done live on the Xpro Clients app. The input included positive and negative integers, as well as positive and negative decimal numbers. We used the matplotlib library in Python to combine the data and analyze the results for each operation in the calculator. According to these results, all 5 operations had a success rate of 100%.
Development of the settings screen involved multiple components of the phone to come together. The first part of ensuring the settings function was to install React Native Settings Library and follow example code on how to use volume and brightness settings to manipulate on the interface. Additionally, the settings example was followed to determine how to change the music on click, to change the volume in various parts of the phone, such as um, ring of the phone or the alarm of the phone or the volume of the music. The location, Bluetooth, and airplane had the same interface but varied in the backend variable that they linked to the library. Our settings page was much easier for a Our settings page is much easier for a tongue controlled device to navigate due to its larger screen appearance and its soothing contrasting colors. Additionally, our settings screen follows ADA code guidelines. Although no formal testing method for the setting screen took place, the setting screen was tested um, by changing the volume through buttons on the phone and verifying that the volume of the setting screen had adjusted accordingly. The same way the location and others on the screen were tested to see if they function as expected.
Hi, my name is Anya. Hi, my name is Anya, and I'm here to present the acknowledgments and give thanks to everybody who helped make this research possible. We want to give special thanks to Dr. Esma Beji. She's the leader in the Wearable team at the UIC's Bioengineering Department. We also want to give special thanks to our mentor, grad student, Sylvia. We want your thesis defense to go well. We also would like to thank everybody at the Early Research Scholars Program. That includes Dr. Ravello and Dr. Hummel for giving us guidance and letting us be on these projects, as well as the grad student Taha, who has helped us every single step of the way. We also need to give thanks to the National Science Foundation for giving funding to the Early Research Scholars Program, as well as to UIC in general for being so welcome and for helping in every possible way. Thank you.
If you have If you have any questions on the development of this application, please feel free to ask any of us in the ERSP group working on the wearable technologies lab. Thank you.